Hello, good evening. BMLS up. Hello, students. BMLS up. We are here to finish the remaining questions on carbohydrate revision. BMLS up. Just tell me in the chat, BMLS up. Welcome, welcome. Welcome again to a live session. Carbohydrate revision. I promise to finish the remaining questions. BMLS up. Hi, Melvin. Lentogioni. Welcome, welcome. We are revising with BMLS up the remaining revision questions which we had last time. So anyone can join if you like to. Yeah, Joy Muringi. Welcome. Hi. Just tell me BMLS up. If you're BMLS up, we are together. Or they could be BCHD students of mine, but we are not yet done with carbohydrates, but it's still okay. I'm finishing with BMLS up, revision on carbohydrates. Just say hi on the chat. I'll hi back. You're most welcome. BMLS upgrading. We need to finish with the carbohydrates revision questions. Hi, Maureen Marlowe. Hey, welcome, welcome. We need to finish with BMLS upgrading carbohydrates revision questions before we can start on proteins, that is amino acids. Wow. BMLS up, just tell me in chat. I'll be able to respond by saying hi. I can see Joy, Melvin, Maureen. I say hi to all of you. You're most welcome. We are finishing with the revision questions, which we started last week. So BMLS upgrading, if you're there, fellow. Felix, just tell me when you're ready on board. Hi, Isaiah, Raja, yeah, hi everyone. BMLS upgrading, anyone on board? Felix, class rep. I'm waiting. We need to discuss about the disaccharides and the polysaccharides, then we can finish today's session. You already did the monosaccharides. I'm yet to finish the remaining bits, as I promised. Welcome. BMLS upgrading. I'm waiting, just tell me if you're already there. Hello, BMLS upgrading, I'm waiting. Let's keep on logging in. BMLS up. BMLS upgrading. Zane, hi. BMLS upgrading. I'm waiting. Felix, class rep. Just tell me when you're there. Hassan, thank you so much. Thank you so much. Thank you so much. Welcome on board. BMLS upgrading, Felix. Everyone just say hi. We welcome you on board. We are revising on the remaining session on carbohydrates. So It's a class on biomolecule. Phoebe, welcome, my dear. Can you tell Felix and the other ones to come on board? Or are you the previous ones? Are you the current BMLS app? The ones who are from the previous class, please just come on board and say hi. And I'm very happy. I congratulate you all when they commented that they passed. I'm humbled, huh? So thank you so much, Phoebe. Already in. Fellow, correct. Please mobilize the other ones to come in. Fellow, hi. I'm happy to see you. Can you tell the other students to come on board so that we can start? But before I start, I'll explain that the country, we were shaken by the news of Honorable Raila Amolo Odinga, and that's why we could always, I kept on postponing, because we are human. Everyone was touched at a certain point. So that's why we couldn't have it on Wednesday, we couldn't have it on Saturday, and I kept on changing it until today. At least things are a bit calmer. So that's why we have to finish today the remaining questions. Fellow, just tell the other ones to come on board. Then I can start. Maybe I give 3 minutes because I don't want to give much time. As we proceed, people will come logging in. Fellow, you will tell me what to do. I'll give 3 minutes. Let's give a bit more time, but not that much. And then we'll be able to proceed from question number 3. As I write on the board, fellow, you'll tell me whether everything is fine, but let's give them 3 minutes. Thank you. Just welcome on board. Welcome, everyone. Okay, they are joining shortly. Thank you so much. Just let them know that we should start in 3 minutes. Then, fellow, I'll also say we've missed 2 of the Fridays. That's a lot, huh? So I'm thinking on Wednesday, we go to our normal class for a makeup, the Microsoft Teams, still at 9. I'm fine with 9. Because since it's a makeup, before we go for the Friday class, so I want us to have one makeup this Wednesday at 9. Or you'll tell me the time, because during the day, you people are very busy at work. So at 9 will be fine. I'll have 1 hour class, makeup class. Then I'll have another makeup next week. We'll be able to organize, because on Friday, we have normal classes as well. So we need to catch up with the 2 Fridays which we've lost. Huh? So, fellow, that one I've just mentioned, we'll be able to discuss as we proceed. You let me know. I'll start. Almost. Fellow, I'll start. I give you 2 minutes, then I'll start. Then they'll keep on joining, because I also need to finish so that people can go to sleep. I don't like taking much time, but I also don't like to start when others are not yet on board. So just let them know to join. And when they join, they just chat there. I can see their names, as Phoebe also mentioned in the chat. So let's keep on subscribing, commenting, because if you comment, we improve positively. Positive comments, that's what I mean. I'll also be able to improve, because I'm also not perfect. So with your comments, I'll be able to know where we can improve. With your likes, with your sharing, people know much about them, about the channel, what you think we should add, It helps us to build much and know much on biochemistry. So it's okay. Let's keep on subscribing and liking, and I don't take it for granted. This far, it's God. And you people, your effort as well has contributed to us reaching this far. So, fellow, you can tell me, because I need to proceed. You can just tell me when it's okay. I proceed, I'll proceed. If you tell me to wait, I'll wait. But then let us not wait for that long. It can be much more longer time until the ones who came early get tired. Millicent, very good. Millicent, yes. Carol, Gio, oh, Gaoluaki, yes. Very good. Fellow, can you give me a go ahead? I proceed with the questions. They'll join as we proceed. Because you already did your part. You already told them that we are having a class. So I think I should proceed from wherever we stopped. Fellow, tell me. Please proceed. Thank you. Kibor, yes, yes, we are welcome. Now, we are going to the question number 3. Fellow has given me an okay. People will join because we need to finish the remaining questions. And for the ones who have joined, I've just suggested that on Wednesday, let's have a makeup class, still at 9, 1 hour, in our teams. So the normal teams, because I need 2 makeup classes. We've lost 2 Fridays. That's a lot. So I need to catch up with the lectures. So before we could stop last time, we already discussed much on the monosaccharides. If somebody has a question of which we also tackled at the point of the chart, maybe after we are done with the revision, before we can start on amino acid during class time, maybe you can ask, because I'll be able to hear what the students say and I'll be able to illustrate. So I'll be able to explain what we didn't get right on Wednesday, that is, before I can start on amino acids. So whatever you didn't get right, as much as we also try to answer much of the questions on the chart, just raise it at the time of class, when we have the teams class. Just raise it, I'll be able to explain. Don't keep quiet if something is not clear, a structure is not clear. So just let me know where you're having difficulty. I'll be able to explain at the time when we are having the class. And even for now, you are allowed to chat, but now on disaccharides and polysaccharides, because we already did much on the monosaccharides. And now let's proceed. Question number 3, which talks about draw structures of sucrose, lactose, maltose, mentioning the monosaccharide component and the type of glycosidic bond found. Celestino, I've seen. Welcome, welcome. Now, my board, today I don't even want to interfere with anything, but you will tell me. I'm going to write on the board as I try to explain. If you don't see anything, I'm going back to my chart to see what the students wrote. Then I need to improve on it. So we are talking about drawing maltose. I think I'll do at the center so that I don't get out of the space for writing, so that the students can see. The disaccharides maltose, sucrose, and lactose. And I mentioned very well, since we are talking about the disaccharides, they have to be drawn in a cyclic form, because the cyclic form promotes their solubility. So you have to mention from me, you have to mention that for maltose is alpha D glucose and beta D glucose. Whatever we are forming is an alpha 1,4 glycosidic bond. Sucrose, alpha D. I thought I had carried things which will not disappoint me, but they will not. Alpha D glucose. Then we have beta D fructose, forming an alpha 1,2 glycosidic bond. For lactose, we have the first monosaccharide component has to be beta D galactose. The second one, beta D glucose. Whatever we are forming is a beta 1,4 glycosidic bond. So if you mention like that, the monosaccharide component, you have to talk about the beta and the alpha. Don't leave the beta and alpha out because we are talking about a cyclic form. So you can't just mention D-glucose, or you can say D-glucose, 2 of D-glucose units, or D-galactose. D-glucose, no, I'm not going to give a mark. So when we are drawing, at least my green one is loyal. When we are drawing maltose, look at that. The first one has to be an alpha D-glucose, meaning whatever I said was the OH group is below the ring. It is the one which is going to determine the type of glycosidic bond formed. So the alpha comes from the alpha D-glucose, the first monosaccharide component. At the first carbon atom of alpha D-glucose and the fourth carbon atom of beta D-glucose. That one is set. So let us put our carbons or OHs in place. We said the OH at the fifth carbon atom will form the hemiacetal. That is the hydrogen, which is at the left-hand side. Remember, it is alpha D-glucose. It means OH is outside at carbon atom number 2, OH inside carbon atom number 3, OH in the same direction or same position as carbon atom number 2 at the fourth carbon atom. Now, it is the same as this because it is also a D-glucose, but now we are talking about a beta. So, if you talk about maltose being a reducing sugar, the presence of the OH at the second glucose component will give it to be a reducing sugar. I'm trying to come back to confirm that whatever I've drawn is visible. So in the same position, I'm going to draw sucrose. Because if I go and draw the sucrose to the farthest right, whether my board is the one which is too small for the space to show, or my light is the one, but then I'll go to the same space. So let me stress much on maltose. We are talking about maltose. The structure on the board is maltose. Maltose, the monosaccharide components are alpha D-glucose and beta D-glucose. Correct. I'll give you mark. Then you mentioned for me the type of glycosidic bond, alpha-1,4 glycosidic bond. Very much correct. But remember, the first monosaccharide component determines the type of bond forming. The OH is below the ring at carbon atom number 1. So, whatever we are talking much about is the OH below the ring. You can easily extend the glycosidic bond downwards. So we'll have at carbon atom number 1 of our alpha D-glucose and the fourth carbon atom of beta D-glucose. So we are forming an alpha-1,4 glycosidic bond. But remember, the D-glucose, you twist it in clockwise direction. Look at the position of the OH at carbon atom number 2. I'll mention this is carbon atom number 2, if we might have forgotten. Carbon atom number 3, number 4, number 5, and number 6. Carbon atom number 1 is this, if we might have forgotten. Then now you look at the second monosaccharide component. It has to be a beta. Look at the OH above. I've just circled it. That is what brings, Millicent, you are welcome. That is what brings the characteristic of maltose as a reducing sugar. It is going to reduce the copper sulfate which is present in the Benedict solution from color blue to the brick red or to orange, depending on how your eyes see the colors, but it is going to change that reagent. We are going to the second disaccharide, sucrose. If you look at sucrose there, I said alpha D glucose and beta D fructose. So if you are talking about alpha D glucose, you already know that for alpha, just the same as the one which we drew. You know, there is this formula which is on our slides, which brings this guy here. Yes? There is this first formula. I'm going to tell you of the second formula. Sorry. The second formula. This is the first formula. Right? The one which is on our slides in class. Our slides have this structure. Our slides. And then you'll choose which one is easier for you. Me, I can draw any, as long as you draw for me the correct thing. So it should be 1, 2. This is carbon atom number 3. It will go inside. 4 outside. 5 is here. The 6th one sits here. That one, whatever you are seeing there, is the one in the notes. Whatever you are seeing there is the one in the notes. So, whatever happens is, the fructose is a beta. The OH is above. That's why you can see there is CH2OH down there. Beta 1, 2 at carbon atom number 1 of alpha D glucose and carbon atom number 2. Don't get stressed and try to ask, why is it carbon atom number 2? What you can note here is at carbon atom number 2, where the second carbon has the keto group, that is where the hemiketal forms. So just note that it is at carbon atom number 2 of beta D fructose and carbon atom number 1 of alpha D glucose. Then it's going to form alpha 1, 2 glycosidic bond. The other way in which it is drawn is this one. The other way. This one is the one which is in the slides. The other one is the first monosaccharide component, is that one. But remember, it has to go down because the glycosidic bond, the OH at the first carbon atom and the second carbon atom. So the other way it is drawn like this. Very simple. But remember, we don't have oxygen there. So at carbon atom number 3, number 4, number 5, and then number 6 will sit here. This is another way of drawing sucrose. Whichever way is simple for you. So you can see the first monosaccharide component, is it visible? Yeah, a bit visible. The first monosaccharide component is an alpha. This one is an alpha. Then it is easy, you extend it downwards, this one. It's easy, you extend it downwards. 1 to carbon atom number 2 of beta D fructose. If you draw that one, I'll give you all the marks. All the marks. Then we have lactose. I think I can draw up here. We have lactose, When you talk about lactose, the first monosaccharide component should be galactose, and that is how I assess. Now, the one in the book is drawing something like this. The one in the slide, sorry, is drawing something like this. I'm going to draw you the other one. It should be here. Something like that. Such that you have galactose, you know, D-galactose, same position. At position number 2, number 3, and number 4, we have OH in the same direction. Now this is glucose, but a beta. A beta. So here you have the bond, CH2, OH, and a H. So that is the one in the slides. The one in the channel is this one. You still have your galactose. Remember, galactose, OH at the 4th carbon atom and the 3rd carbon atom are on the same direction. So the one you go up, no, sorry, you go up, so you go up, you come down, then you go up. That one is lactose. But remember the presence of the OH at carbon atom number 3. CH2, OH, and H. Wait. H, 1, 2, 3, 4, 5, 6. Here, the position of the OH, I want to stress here, the same position. Carbon atom number 3 and number 4. That one makes it clear. That is lactose. Reducing sugar as well, the presence of this. The OH, which is present on beta D glucose, brings much of the reducibility as a reducing sugar. When you add the Benedict reagent, lactose and maltose are going to change it from blue to brick red. But for sucrose, you saw all the monosaccharide components are involved in the formation of the glycosidic bond. So sucrose is a non-reducing sugar. If you'll be able to do those tests in the university, you will realize that it retains the blue color. Is there a way you can improve on visibility? Oh, sorry. Felix, it doesn't show. Today I don't even want to disturb the peace of the board. Fellow, you'll tell me if you can see it a little bit. So we are talking about those disaccharides. If you are trying to look at the disaccharides, which are reducing sugars and non-reducing sugars, it will tell much by how they change the copper sulfate, which is present in the Benedict solution. But that one tells much by the presence of the OH on the second monosaccharide component of lactose, which is beta D galactose, beta D glucose, sorry, and the presence of the OH on the second monosaccharide component in maltose, which is a beta D glucose. glucose. So the presence of the OH contributes much to those sugars reducing the reagent, Benedict reagent, that is. So question number 4 says, write short notes on similarity and differences between cellulose and amylose. This one I can just discuss by saying, not drawing. If you talk about cellulose and amylose, you talk about their similarity. You can't say that they are both homopolysaccharide. No, that is not an argument which makes sense for a bachelor student. In fact, I should specify structural difference. If you talk about the structural difference and structural similarity, you say that cellulose, structural difference, cellulose is a polymer of beta D glucose units, while amylose is a polymer of alpha D glucose units, or alpha D glucose. The other one is beta D glucose, meaning cellulose will form a beta 1,4 glycosidic bond. Amylose will form an alpha 1,4 glycosidic bond. But then their similarities is they are both linear. They are not branched at a certain point, if you could remember. Starch, amylose is a component of that starch. We have amylose and amylopectin. Amylose is linear, only has the alpha 1,4, a polymer. You see, we already know how to draw the alpha D glucose. It will be a line, a polymer of all those glucose units, but then alpha 1,4, alpha 1,4. For cellulose, it will be beta 1,4, beta 1,4, forming a polymer. And we talked about amylose, it could even go even for 2,000 glucose units. So it's a polymer of alpha D glucose, while cellulose is beta D glucose. But then the other point which we said was simple, was that similarity is they are both linear. No branches, no beta 1,6, no alpha 1,6. They are both linear. Simple as that. Write short notes on similarities and differences between glycogen and amylopectin. Differences and similarities. Differences and similarities. Differences are glycogen, a form of carbohydrate which is found in animals, and we are the animals. It could be animals which are dogs, humans, whatever, but we are all under the class of Animalia, whatever. Yes, I'm not good much in taxonomy, but it's found in animals, a form of carbohydrate in animals, while the other one is a form of carbohydrate in plants. So the similarity is amylopectin and glycogen, they are both branched. Another difference, apart from where they are found, one being in animal, the other one in plants, glycogen is more branched than amylopectin. That's another difference. Because you will look at glycogen, you will meet 8 to 10 glucose units, then you'll meet a branching point. But then for amylopectin, it can take 20 to 30 of those glucose units is when you meet a branching point. So amylopectin is less branched. Or you can, the other way you can say glycogen is more branched than amylopectin. You can see I talk about write short notes. It means there is no drawing. Where I need structures, I'll just tell you, draw for me structures. Then we talk about 5 medical importance of hyaluronic acid. Could you remember where we did hyaluronic acid, right? We did heteropolysaccharides. Heteropolysaccharides. And if you talk about the heteropolysaccharides, now where the glucosamine and the galactosamine were coming in, there is another functional group apart from only the monosaccharide component found there after hydrolysis, but you have another component on top of the simple monosaccharide component, which you should see when the homopolysaccharides are hydrolyzed. So we saw hyaluronic acid as one of those examples. But then when we looked much at the medical importance of this heteropolysaccharide, they were very simple. We talked much about the hyaluronic acid having a component of N-acetylglucosamine together with a glucuronic acid. So if you talk about the glucuronic acid, there is a glucose, but then it's an acidic of those sugars. So we talk about the N-acetylglucosamine, which we drew last week. The presence of the acetate there, the presence of the amine group, they form the component of the HA, the hyaluronic acid. And this hyaluronic acid had very important points based on the medical importance. We talked about wound healing. We talked about scars formation. We talked about the eye. So they give much of the clearance, the vision. We talked much about the joints. As people get old, there is pain on the joint. That means the hyaluronic acid is reducing, where it's now being substituted by dimethyl sulfate. So it brings much of the pains of the joints. We talked much about the collagen, that is the vitreous, which is clear, which relates much with the eye. So as the age advances, vision becomes a problem. It means there is a problem which is now related to the HA, because now it is of low level. Then we talk about tumor cells. The HA is involved in migration of the tumor cells. So we also talked much about the skin, the content of the skin. As the age advances, you'll always be susceptible to scar formation, because the HA, the hyaluronic acid, now it's a bit less, or its content is less on the skin. So those were most of the medical and biological importance. So if somebody talks about where were we? When somebody talks about the 5 medical importance of HA, I've just said list. So maybe you can list without explaining much how it happened. It helps much in vision. It helps much in wound healing, in scar formation, migration of those cells, or it promotes much of those tumor cells to migrate. Then just mention, we'll get the 5 marks. And then I gave question number 7. Structures in each case, discuss 2 criteria for naming of monosaccharides. This one, we could have, Jackie, hello. Diamond Lab, hello. So I'll draw on the board if we might have forgotten, but what we did last week on monosaccharides and their structures will tell much about our question number 7. But now, please, when I ask such a question, don't draw for me the cyclic form. I want the linear form so that you can explain for me where the functional group is. You can explain for me the number of carbon atoms in the main skeleton. So let me go back to the question. 3 structures in each case. Discuss 2 criteria. What I need in this question is simple. The 2 criteria you'll first mention based on the functional group you'll get a tick. Based on the number of carbon atoms in the main skeleton, you get a tick. Then come now, explain functional group. Ketosis at carbon atom number 2, where the keto group is. They are known as ketoses. Aldosis at carbon atom number 1, where the aldehyde group is. Then draw for me any. I could remember telling the students when we had the class of the monosaccharides of the criteria, I told you maybe you can go while reading on your own, you check on how to draw the 3 carbon sugars which are having the aldehyde group, the 4 carbon sugars which are having the aldehyde group, the 5 carbon sugars which are having the aldehyde group. Same, the 3 carbon sugars which have the keto group, as well as the 4 carbon sugars which are having the keto group. And it's very simple. I told you it is very simple. We are talking about naming of monosaccharides based on the functional group. I'm going to check when I sit down if it's visible, as fellow had requested. So you are talking about 3 carbon sugar, 3 carbon. Based on the number of carbon atoms, that one is a triose. Does it show? I'm trying to make it a bit better. I don't want to interfere with what the DJ has set here. The DJ has tried to set my camera today. So we have CH2OH, C double bond O, CH2OH. The keto group at carbon atom number 2, at carbon atom number 2. Keto. So it means, first one, you are talking about criteria for naming of monosaccharide. You will tell me functional group. Then you say ketosis, they have keto group at carbon atom number 2. Example, you will draw, that is dihydroxyacetone. Then you will also have this one. We have an aldehyde group. So you will be able to talk about aldosis at carbon atom number 1. And I told you, balance the bonds around the carbon. If you look at the atomic configuration, atomic number, carbon will have 6. And that's how it will be. 2 to 4, around that carbon, make sure the bonds are balanced. They should not be excess, neither should they be less. At carbon atom number 1, we are talking about the functional group. You have to mention the carbon atom number 1. It has the aldehyde group. So they are known as aldoses. You will draw for me that one. I said 3 structures. So you can either draw for me 2 of the ketoses, but then different carbon atoms, or 2 of the aldoses and 1 ketose, whichever way you want. But me, I want 3 structures, but not the same carbons. You can see, as long as there are 3 carbons, but they are of different functional groups, I'll know you are describing the functional group. Such that when you go to the number of carbon atoms, you don't draw these 2. You draw only 1 to express that 3 carbons are known as trioses. So don't draw this and you leave that it covers both functional group and number of carbon atoms. No, it is you to explain to me the answer which you are giving me, not me to add and say, oh, the student was having this idea. No, put it clearly. Ketosis, draw for me dihydroxyacetone. You'll talk about the keto group, carbon atom number 2. Aldosis, you'll talk about the glyceraldehyde. Circle at carbon atom number 1, the aldehyde group, and then it's still 3 carbon atom. Then you will go to the next one, where now, so here you can add one of them, hexoses. You can either add for me fructose, or you can even add glucose. It is still okay because I need 3. But you have to explain to me that at that point you are talking about the functional group which are there, not the number of carbon atoms. So if you're talking about the number of carbon atoms, this is where you'll have a lot of work, because as much as I've drawn the 3 carbon, I'll draw it again. You know, here, even if you give me all aldehyde groups, I don't mind, as long as you are trying to explain to me that you understand my question. Now, I need the 3 carbons, the 4 carbons, as well as the 5 carbons. Just give me something. Give me something which can show that you understand my question very well. This is ribulose I'm drawing. This is ribulose. Look at that. Imagine. That is how simple a question is, if you understand it. That is the number of carbon atoms in the main skeleton. The upper one to the farthest, which I started with, was 3 carbon atoms. So it is the first carbon in ketosis. What you have to know, the first carbon has to be CH2OH. The second carbon has to be a keto group. Then play around with the number of carbon atoms. For me, the last carbon will always be CH2OH. So the first one I've drawn dihydroxyacetone. The second one I've drawn, I drew the erythrose, sorry. I've drawn erythrose, which is a tetrose. And then I've drawn ribulose down here. So as much as it's 5 carbon atom, you'll say based on the number of carbon atoms, 3 carbon atoms known as triose, draw dihydroxyacetone or glyceraldehyde. 4 carbon atoms tetroses, draw erythrulose or erythrose. 5 carbon atoms talk about pentoses, draw ribulose, ribose, xylulose, xylose, any of those. And then the 6 carbon, which are hexoses, you already know most of them. We have galactose, we have glucose, we have mannose. You can draw any. That is how this question is answered. You have to start by mentioning the criteria. Functional group 1, tick. Second, number of carbon atoms in the main skeleton, tick. Then explain functional group. Keto group at carbon atom number 2. They are known as ketoses. Draw several ketoses, which you know. Be it 3 carbon, 4 carbon, 5 carbon, 6 carbon. If I want 4, each one of them, draw for me. Draw for me the aldoses. Draw for me the ketoses. You will get your mark. Then you come to the second criteria. Now explain about the number of carbon atoms in the main skeleton. It has to start from 3. Because 2 is disaccharide. 3 carbon, triose, 4 carbon, tetrose, 5 carbon, pentose, 6 carbon, hexose. Imagine you'll be getting marks for telling me that triose is 3 carbon, 4 carbon, 5 carbon. You'll get marks for those. Then go and draw the structures. That is how I work. And I'll give you all your marks. I'll not even leave even one. Because what I'm trying to test there, do the students know how to draw the structures? Can they tell the different functional groups while drawing this monosaccharide structure of these simple sugars? That's how simple it is. So by getting the point and putting the point, don't go round and round, having 3 pages, still writing what you don't know what you're writing about. No, go straight to the point. And that's why I still tell you, chemistry was easier than even biology. Because you can prepare for exams only with 3 pages, as long as the equations are balanced. You know all the 20 elements, periodic table, and you know how to balance the equation, you are good to go. But biology, it needs you to read and understand things the way they happen systematically. It doesn't mean that both of them are hard. No, they need one another for us to understand them. So for me, if you describe much of what I ask by structures, that is my secret. If you can draw structures well, then you can easily pass. But we have to understand the structures we are drawing. We don't cram. And then question number 8, I think I've already discussed it. Disaccharides in detail, including structures, monosaccharide components, and glycosidic bond. So what I mean here, you can see it's 20 marks. What I mean here is all the stories which you need to confess of all these disaccharides. If it is maltose, we start about the malt sugar. You go much and talk about the maltose. It's found in whatever. All those stories. If it is lactose, talk about the milk sugar, the lactose intolerance, whatever was all those theory, which was on those. Then you support with the structures. Same with sucrose, the sweetest of all, related to the dental caries. You could remember all those stories which you wrote. I want you to confess all those stories about those disaccharides on that question because it's 20 marks. Then the structures will carry a lot of marks, but then we have to draw them right. So for the monosaccharide components, kindly you have to mention the beta, D-galactose, beta, D-glucose for lactose, beta, D-glucose together with the alpha-D glucose for maltose. Then you have to talk about alpha D glucose and beta D fructose for sucrose. We are talking about discuss any 3 homopolysaccharides. So aside of glycogen, but then most of the marks will go for the starch, the glycogen, and the cellulose, because the other homopolysaccharides, which we learned much, like the inulin and dextran and chitin, they don't have much of information, because what we already knew much on dextran was that it is linear and branched at the same time. But we have the linear part, we have the alpha 1,3, and still the branching point, we have the alpha 1,6, but it has the alpha D glucose units. Then we are talking about inulin at the time you are doing the kidney function tests. So we are talking about how the glomerular filtrate is tested. How long does the kidney take to release such waste? Inulin is a component. But now, inulin is a component of fructose. Mostly, we don't rely much on it. We'll always have creatinine tests being done. Inulin, the reason they're giving much is it will not give us reliable results because it will be affected by diet. So the result which we might get from inulin clearance tests might not be reliable much. So we always do creatinine tests, but what I wanted to bring about is it is a test which is always done when in relation to see how the kidney as an organ also functions. So inulin is also one of the homopolysaccharide, but remember the component is beta D fructose, and we have the beta 1,2 glycosidic bond which is forming, and then chitin we have the beta 1,4. So you can discuss any of the 3, but what I'm saying, if you go as far as discussing dextran, inulin, and chitin, you won't get enough marks because I need 20 marks. At that point when I need 20 marks, I need you to discuss much about starch, because you know starch, it is very vast. You are going to discuss about amylose. You are going to discuss about amylopectin, the components of amylose, the component of amylopectin, based on the structures, which one is branch. You'll have a lot of information. And then you come now to glycogen, and then maybe cellulose. So mostly in this question, I'm focusing much on the first three homopolysaccharides because you'll have enough information. Or either way, what I can do, I can specify, discuss cellulose, glycogen, and starch. Then that will be fine. Because if I leave it like this, and then a student does the dextrin and the inulin, you'll give a marks, but then it will be less. So we just have to put points clear. Then it talks about discuss any three heteropolysaccharides. Even at that point, when I'm talking about heteropolysaccharides, I'm focusing much on hyaluronic acid, because hyaluronic acid can give almost 10 of the marks of the 20. If you do hyaluronic acid, you just describe the components there. We already talked much about the N-acetyl glucosamine and the glucuronic. And then you go to damatane sulfate, because hyaluronic acid has a lot of information than the other heteropolysaccharide, where we had the damatane sulfate. You had also the carata sulfate 1 and 2, any of those which we discussed. Even the heparin fall under there, the anticoagulant. So you'll be able to discuss any of the three heteropolysaccharides without drawing their structures, but you have to discuss the monosaccharide component in those heteropolysaccharides. So when any of those questions come, we will be able to know how to answer them. Yes, it's exactly 2 minutes, then it clocks an hour. So I'm done with the revision for carbohydrates. And I confidently know that even if I would bring an exam today, which has also only all carbohydrates, I might bring it today, then I shall do my part. I shall have done my part. The students can score a 70, that is an A and above. So what I wanted to say was, now I can see the students already come a little bit. Kindly, on Wednesday at 9, we go to our Microsoft team. We log in. We need to have the first makeup class. We've missed 2 of the Fridays. A holiday is a holiday. I'll not fix the students to study like the world is ending today. No. A holiday is a holiday. Jenny, yes, I can see you. A holiday is a holiday, and the students must relax their mind. But we've missed 2 Fridays. So, fellow, I already mentioned it when we were starting. Let's have a class Wednesday at 9 p.m. I know daytime, you people are busy at work, because that day I can also schedule a time during the day. But I know at night it's fine. Everyone is already maybe at home or already finished with the day work. So we can just try to adjust. For only 1 hour, we do the first makeup. Then we'll have our normal class on Friday. Then we'll organize another makeup. Then the makeups will be fine. So, fellow, you'll just let me know. But let us have it on Wednesday in the normal Teams, the Microsoft Teams for the university. So I think that is well understood. If somebody has a question, maybe you can ask me in the chat. But for now, I must say I'm very grateful. So I still also started by explaining why we didn't have our class. We scheduled on Wednesday, we changed from Wednesday to Friday, and all has happened. We are human. We were touched at a certain point with the passing of the Right Honorable Raila Odinga. So at least today things were a bit calm, as much as we haven't settled much. But we had to do it today to prepare us to start amino acids on Wednesday. So I thank you all. Keep on subscribing, keep on revising, Keep on liking, keep on commenting. I love you all, my students, and you people are the best. May God bless you and have a good night.